Mars. The very name evokes a sense of wonder, a sense of mystery that has captivated humanity for centuries. This red planet hanging in the night sky has been a source of inspiration and curiosity, a celestial beacon that calls out to us with the promise of alien landscapes and untold secrets. As we gaze upon Mars, shimmering with its reddish hue, we can't help but imagine the possibilities that lie beneath its surface. What stories does this planet hold? What secrets are waiting to be uncovered? The allure of Mars is undeniable, a tantalizing glimpse into a world that is both familiar and profoundly alien. Since antiquity, humans have been fascinated by this red point of light in the sky. Ancient civilizations wove tales of gods and monsters, imagining that Mars was home to powerful deities or fearsome creatures. The Greeks named it after their god of war, Ares, while the Romans called it Mars. These myths and legends have persisted through the ages, fueling our imagination and our desire to explore this distant world. Today, we are no longer limited to just imagining what lies on Mars. Armed with the tools of science and driven by an insatiable curiosity, we are peeling back the layers of this enigmatic planet. Through the use of advanced technology, we are able to send rovers and spacecraft to Mars, capturing detailed images and conducting scientific experiments that reveal a world that is both familiar and alien. Our fascination with Mars stems from its tantalizing proximity to Earth and its potential to harbor life. Unlike the scorching hellscape of Venus, or the gas giants beyond, Mars whispers of possibilities. It is a planet that has the potential to reveal the history of life in our solar system, or perhaps even the presence of life itself. The discovery of water channels and dry riverbeds on Mars suggests that water once flowed freely on its surface, raising the possibility that life may have once existed there. The presence of these ancient water channels and riverbeds is a tantalizing clue that Mars may have once been a more hospitable place. Scientists believe that billions of years ago, Mars had a much thicker atmosphere and a climate that could have supported liquid water on its surface. This raises the possibility that life may have once taken hold on Mars and that the planet may still harbor microbial life in its subsurface. The journey to unravel the mysteries of Mars is a testament to human ingenuity and our relentless pursuit of knowledge. Each mission to Mars, each rover that traverses its alien plains, is a step closer to understanding this enigmatic world. The engineers and scientists who work tirelessly to design, build, and launch these missions are driven by a shared goal: to uncover the secrets of Mars and to expand our understanding of the cosmos. Each image beamed back to Earth, each data point collected brings us closer to understanding Mars and our place within the universe. The discoveries we make on Mars have the potential to reshape our understanding of the solar system and our place within it. As we continue to explore this red planet, we are reminded of the boundless possibilities that lie beyond our own world and the endless potential for discovery that awaits us in the cosmos. The first thing that strikes us about Mars is its distinctive red hue, a consequence of iron oxide or rust prevalent in its soil. This iconic color has earned Mars the nickname the Red Planet, and it has fascinated astronomers and scientists for centuries. The iron oxide, which gives Mars its reddish appearance, is not just a surface feature, but a key to understanding the planet's complex history. This rusty dust, a testament to a past rich in water and oxygen, blankets the planet, obscuring the secrets that lie beneath. The Martian dust storms, some of the largest in the solar system, can engulf the entire planet, creating a veil that hides the surface from view. These storms are not just a meteorological phenomenon, but a window into the planet's atmospheric dynamics and climatic changes over eons. But this red veil is not just a superficial coating, it holds clues to the planet's history, its past climate, and the potential for ancient life. The layers of dust and soil on Mars are like pages in a history book, each one telling a story of a different era. By examining these layers, scientists can uncover the environmental conditions that existed on Mars billions of years ago. Scientists believe that billions of years ago, Mars was a much warmer and wetter world, with rivers, lakes, and perhaps even oceans gracing its surface. These ancient water bodies could have provided the necessary conditions for life to develop. The evidence of these ancient waterways is etched into the Martian landscape, with dry river channels and lake beds offering tantalizing hints of a more hospitable past. The iron in the Martian rocks reacted with this ancient water and oxygen, creating the iron oxide that gives the planet its characteristic color. This process, known as oxidation, is similar to the rusting of iron on Earth. The presence of iron oxide on Mars suggests that the planet once had a thicker atmosphere and a more active hydrological cycle, which could have supported liquid water on the surface. Analyzing the composition and distribution of this red dust provides valuable insights into Mars's geological history and the processes that shaped its surface. The rovers and landers sent to Mars are equipped with sophisticated instruments that can analyze the chemical and mineralogical composition of the soil and rocks. These analyses help scientists understand the planet's volcanic activity, weathering processes, and the role of water in shaping the Martian landscape. By studying the different layers of sediment, scientists can piece together a timeline of Mars's past, revealing periods of intense volcanic activity, periods of flowing water, and perhaps even glimpses into environments that could have supported life. Each layer of sediment is like a chapter in the planet's history, providing clues about the environmental conditions that existed at different times. The discovery of certain minerals, such as clays and sulfates, indicates that liquid water was present on the surface for extended periods, creating potentially habitable environments. The polar ice caps on Mars, composed of water and carbon dioxide ice, also hold important clues about the planet's climate history. Seasonal changes in the ice caps provide insights into the planet's current climate dynamics, while the presence of ancient ice deposits suggests that Mars has experienced significant climatic shifts over its history. Some scientists even speculate that ancient oceans may have existed in the northern plains, covering large portions of the planet's surface. The ongoing exploration of Mars by rovers like Curiosity and Perseverance continues to uncover new information about the planet's geology, climate, and potential for life. These missions are not just about exploring the surface, but also about understanding the planet's interior and its geological processes. By studying Mars, scientists hope to gain a better understanding of the early history of the solar system and the conditions that led to the development of life on Earth. As we look to the future, the exploration of Mars holds the promise of new discoveries and the potential for human settlement. Concepts for future Mars habitats and colonies are already being developed, with the goal of establishing a human presence on the red planet. The knowledge gained from studying Mars's past will be crucial in planning for its future, as we seek to unlock the secrets beneath the rusty veil and pave the way for a new era of exploration and discovery. While the present-day Martian surface appears dry and desolate, evidence points towards a water-rich past. The red planet, with its barren and dusty plains, was not always the lifeless world we see today. Scientists have uncovered compelling evidence that suggests Mars was once a planet where water flowed abundantly, shaping its terrain and possibly nurturing life. Vast networks of ancient river valleys snake across the planet, their meandering paths etched into the landscape, silent testaments to a time when liquid water flowed freely on Mars. These valleys, carved by the relentless flow of water, tell a story of a dynamic and changing environment. The channels, some stretching for hundreds of kilometers, indicate that water once played a significant role in sculpting the Martian surface. These valleys, some comparable in size to the largest rivers on Earth, tell a tale of a planet once teeming with water, a stark contrast to the arid world we see today. The comparison between Martian and Earth river valleys reveals striking similarities, suggesting that the processes that shaped Mars were not so different from those on our own planet. This realization opens up new avenues for understanding the history and evolution of Mars. Further evidence of this watery past lies in the numerous lake beds scattered across the Martian surface. These ancient lakes, now dry and barren, once held vast amounts of water. The remnants of these lakes provide crucial clues about the climate and environmental conditions that prevailed on Mars billions of years ago. These depressions, some containing minerals that form in the presence of water, suggest the existence of long-lived lakes and even potential inland seas. The discovery of these minerals is significant because they can only form in the presence of water, indicating that these lakes were not fleeting phenomena, but rather stable bodies of water that existed for extended periods. The presence of these ancient water bodies paints a picture of a Mars that was once much warmer and wetter, a place where life, as we know it, could have potentially thrived. The idea of a warmer and wetter Mars is supported by climate models and geological evidence, which suggests that the planet had a thicker atmosphere capable of supporting liquid water on its surface. The search for water on Mars is not just an academic pursuit, It is fundamental to understanding the planet's habitability and the potential for past or even present life. Scientists are particularly interested in finding evidence of water because it is a key ingredient for life. By studying the history of water on Mars, researchers hope to uncover clues about the planet's potential to support life, both in the past and possibly even today. Water is essential for life as we know it, and its presence on ancient Mars raises tantalizing possibilities about the existence of Martian life forms, however simple, that may have existed billions of years ago. The discovery of water on Mars has profound implications for our understanding of the universe and our place within it. If life did exist on Mars, it would suggest that life is not unique to Earth, and that the conditions necessary for life can arise in diverse environments across the cosmos. This realization fuels the ongoing exploration and study of Mars as scientists continue to search for signs of past or present life on the red planet. The quest to uncover Mars's watery past is a journey that combines cutting-edge technology with human curiosity. Rovers like Curiosity and Perseverance are equipped with sophisticated instruments designed to analyze the Martian soil and rock, searching for signs of water and life. These missions are not only about exploring a distant world, but also about answering fundamental questions about the origins and distribution of life in the universe. As we continue to explore Mars, each new discovery brings us closer to understanding the planet's history and its potential to harbor life. The vision of ancient Mars, with its flowing rivers and vast lakes, is a reminder of the dynamic and ever-changing nature of planets. It challenges us to rethink our assumptions about where life can exist and inspires us to keep searching for answers in the most unlikely places. The whispers of ancient waters on Mars are more than just echoes of the past. They are a call to explore, to discover, and to understand. They remind us that the universe is full of mysteries waiting to be uncovered, and that the search for knowledge is a journey without end. As we look to the future, the story of water on Mars will continue to inspire and guide our exploration of the red planet and beyond. A second home Mars beckons. The cosmos, in its infinite vastness, holds countless mysteries. Among these celestial wonders, Mars stands out, a beacon of possibility, a testament to our unquenchable thirst for exploration. For centuries, we have gazed at this red planet, captivated by its enigmatic allure. Could Mars, our cosmic neighbor, hold the key to our future? Could we one day call this alien world our second home? The idea, once relegated to the realm of science fiction, is now within the grasp of human ingenuity. We stand on the precipice of a new age of exploration, one where the dream of establishing a self-sustaining colony on Mars is no longer a distant fantasy, but a tangible goal. This ambitious endeavor, however, will require not only technological prowess, but a collective spirit of unity and a deep respect for the delicate balance of the Martian environment. The challenges are monumental, the risks undeniable, yet the potential rewards are even greater. Imagine a future where humanity becomes a multiplanetary species, where the spirit of exploration pushes us to new frontiers, fostering innovation and expanding our understanding of the universe. This is the promise of Mars, a promise of a future where the limits of human potential are constantly redefined, where the spirit of exploration burns brighter than ever before. The journey to Mars will be a testament to the indomitable human spirit, a testament to our ability to overcome seemingly insurmountable challenges. It is a journey that will inspire generations to come, a journey that will redefine our place in the cosmos. Let us therefore embrace this challenge not with fear or trepidation, but with the courage, curiosity, and unwavering determination that have always defined our species.
Transforming Mars into a habitable world, a second Earth, is a daunting but not insurmountable task. The process, known as terraforming, involves a series of calculated interventions aimed at altering the Martian environment to make it more hospitable to life as we know it. One of the primary goals is to thicken Mars's thin atmosphere, which is predominantly composed of carbon dioxide. This can be achieved by releasing trapped greenhouse gases from the planet's polar ice caps and regolith, the layer of loose, unconsolidated material covering the bedrock. These greenhouse gases, once released, would trap more solar radiation, gradually warming the planet and thickening the atmosphere, making it more suitable for liquid water to exist on the surface. Introducing specially engineered microorganisms into the Martian environment could further enhance this process. These microbial pioneers would play a crucial role in converting carbon dioxide into breathable oxygen, slowly but steadily transforming the Martian atmosphere into one that can support Earth-based life. This biological approach, combined with more industrial-scale methods, offers a promising pathway toward terraforming. However, terraforming Mars is not a quick fix. It is a multi-generational project, a long-term investment in our future. We must approach this monumental task with patience, careful planning, and a deep understanding of the potential consequences, both intended and unintended.
Water, the elixir of life, is crucial for any hope of establishing a permanent human presence on Mars. Fortunately, Mars is not entirely devoid of this precious resource. Evidence suggests that vast reserves of water ice are locked beneath the Martian surface, remnants of a wetter, warmer past. Extracting this subsurface water will be a key challenge. One proposed method involves using specialized drilling equipment to access these underground reservoirs and then heating the ice to release liquid water. This water can then be purified and used for a variety of purposes, from drinking and agriculture to generating oxygen through electrolysis. Another potential source of water lies in the Martian atmosphere, albeit in the form of vapor. Advanced atmospheric condensers, similar in principle to the dew collectors used in some arid regions on Earth, could be deployed to capture and condense this atmospheric moisture, providing a continuous, albeit limited supply of water. Managing and conserving this precious resource will be paramount. Innovative water recycling and purification systems will be essential for creating a closed-loop system where water is used and reused efficiently, minimizing waste and ensuring the long-term sustainability of the Martian colony.
Section 4. Martian farms, cultivating a new Eden. Sustaining a human presence on Mars requires more than just air and water. It demands a reliable source of food. Traditional farming methods, reliant on fertile soil and open fields, will need to be adapted for the harsh Martian environment. The solution lies in controlled environment agriculture, specifically hydroponics and aeroponics. Hydroponics involves growing plants in nutrient-rich water solutions, while aeroponics takes it a step further, suspending plant roots in the air and misting them with nutrient-rich solutions. These methods eliminate the need for soil, reduce water consumption, and allow for precise control over environmental factors such as temperature, humidity, and light. The Martian regolith, though not ideal, can be enriched with organic matter and beneficial microbes to create a more hospitable growing medium. This hybrid approach, combining the advantages of soilless cultivation with the potential of Martian soil, could pave the way for a more diverse and sustainable Martian diet. Imagine Martian greenhouses bathed in the soft glow of artificial sunlight, where rows of leafy greens, plump tomatoes, and vibrant fruits thrive, providing sustenance and a touch of earthly beauty to the red planet. These Martian farms, a testament to human ingenuity, will be vital for the survival and well-being of the Martian colony.
Section 5. Building a home on Mars, a fusion of technology and tenacity. Constructing habitats on Mars presents a unique set of challenges and opportunities. Transporting vast quantities of building materials from Earth is not feasible, necessitating the use of locally available resources. Fortunately, the Martian regolith, though seemingly barren, holds the key to constructing our Martian homes. One promising approach is to utilize Martian soil in a process similar to 3D printing. By mixing the regolith with binding agents and using solar or nuclear-powered 3D printers, we can create sturdy, durable structures layer by layer. These structures can then be sealed and pressurized to create a safe, habitable environment for humans. Another intriguing possibility is to create subterranean habitats, taking advantage of the natural insulation provided by the Martian soil. These underground dwellings would offer protection from the harsh radiation environment on the surface, as well as from temperature extremes and micrometeoroid impacts. The design of Martian habitats will need to prioritize functionality, sustainability, and the psychological well-being of the inhabitants. Incorporating elements of nature, such as indoor gardens and water features, will be crucial for creating a sense of peace and tranquility in this alien world.
Section 6. Life under a crimson sky. The human element. Life on Mars will be unlike anything we've ever experienced on Earth. The lower gravity, the confined living spaces, the constant awareness of our isolation from our home planet, these factors will undoubtedly have a profound impact on the human psyche. Addressing the psychological well-being of Martian colonists will be paramount. Creating a sense of community, purpose, and connection to Earth will be vital for maintaining morale and mental health. Advanced communication technologies will play a crucial role in bridging the vast distance between Earth and Mars, allowing for real-time interaction with loved ones, access to entertainment, and a continued sense of belonging to the human family. The Martian environment, with its unique challenges and opportunities, will likely foster a new spirit of self-reliance, innovation, and community. The colonists, faced with shared challenges, will need to work together, relying on each other's strengths and supporting each other through adversity. This shared experience will forge strong bonds, creating a new chapter in human history, one where the pioneers of Mars, bound by their common purpose, write a new narrative of human resilience, adaptability, and the enduring power of the human spirit.
Section 7. The Ethics of Colonization, a Cosmic Responsibility. As we venture into this new frontier, we must proceed with caution and a deep sense of responsibility. The colonization of Mars raises profound ethical questions that we, as a species, must grapple with. The foremost of these is the potential impact on any indigenous Martian life. While current evidence suggests that Mars is currently uninhabited, we cannot rule out the possibility of microbial life existing beneath the surface. Any terraforming efforts must therefore be conducted with extreme care, ensuring that we do not inadvertently harm or extinguish any native Martian organisms. Furthermore, we must consider the ethical implications of altering another planet to suit our needs. Do we have the right to impose our presence on a world that has existed for billions of years, potentially irrevocably altering its environment? Or should we strive to find ways to coexist with Mars, respecting its unique character and preserving its natural wonders for future generations? These are not easy questions, and there are no simple answers. However, by engaging in open and honest dialogue, by seeking guidance from experts in various fields, and by prioritizing ethical considerations in all our endeavors, we can strive to ensure that our journey to Mars is one of respect, responsibility, and a deep appreciation for the delicate balance of life both on Earth and beyond.
For centuries, we have gazed at the stars. We have wondered about our place in the cosmos. Among these celestial wonders, Mars holds a special allure. Its rusty red surface beckons us with the promise of discovery. Today, we stand on the cusp of a new era. We aspire for more than just a visit. Imagine a Mars with blue skies and flowing water. Picture lush fields and bustling cities. This is the audacious goal that drives us. The journey will be fraught with challenges. Mars presents a harsh and unforgiving environment, yet the rewards are immeasurable. Transforming Mars is about safeguarding our future. It's about expanding our horizons and ensuring the survival of our species. It's about answering a fundamental question: are we alone? Mars is a planet of stark contrasts. Towering volcanoes pierce a thin, cold atmosphere. Vast canyons scar its surface, remnants of a turbulent past. This alien beauty masks a harsh reality. The Martian atmosphere is incredibly thin. It offers little protection from the sun's radiation. Temperatures plunge far below freezing at night. The lack of a global magnetic field exacerbates the challenges. Without it, Mars is bombarded by radiation. Water exists primarily as ice, locked beneath the surface. Overcoming these challenges will push the boundaries of human knowledge and innovation. Creating a self-sustaining biosphere on Mars requires understanding the delicate balance of Earth's own ecosystems. Life on Earth exists in a complex web of interdependence. Plants produce oxygen, animals exhale carbon dioxide, and microorganisms break down organic matter, recycling nutrients back into the ecosystem. Replicating this intricate dance of life on Mars is a monumental task. We must carefully select organisms that can survive the Martian environment. These pioneers, known as extremophiles, exist even in Earth's most extreme environments, from scorching deserts to frozen wastelands. By studying these hardy organisms, we can gain insights into how life might thrive on Mars. Genetically engineered organisms adapted to Martian conditions could play a crucial role in this process. Imagine algae blooming in Martian ice, releasing oxygen into the atmosphere. Picture genetically modified bacteria enriching the soil, making it suitable for plant growth. These are not just flights of fancy, they are the building blocks of a Martian ecosystem. Terraforming, the process of transforming a planet to resemble Earth, has long been a staple of science fiction. But could we actually terraform Mars, turning it from a cold, arid desert into a habitable world? The concept is audacious, but not entirely outside the realm of possibility. One proposed method involves releasing greenhouse gases into the Martian atmosphere. These gases would trap heat, warming the planet and potentially melting the polar ice caps. This in turn could lead to the formation of oceans and a denser atmosphere. However, terraforming Mars would be a monumental undertaking, requiring vast amounts of energy and resources. It would also raise profound ethical questions. Do we have the right to fundamentally alter another planet, even if it means ensuring our own survival? The debate over terraforming is likely to continue for generations, but the very act of contemplating such a project speaks to the boundless potential of human imagination and our determination to push the boundaries of what's possible. Section 5. The essential element, unlocking Mars water. Water is the lifeblood of any ecosystem, and Mars possesses a surprising amount of it. Vast reserves of water ice lie trapped beneath the Martian surface, remnants of a wetter past. Accessing this frozen treasure is crucial for any hope of sustained human presence on Mars. One proposed method involves drilling into the Martian subsurface and heating the ice, creating underground reservoirs of liquid water. This water could then be used for drinking, irrigation, and even for generating oxygen through electrolysis. Another approach involves capturing and condensing atmospheric water vapor, a process already used in arid regions on Earth. While Mars's atmosphere is thin, it does contain trace amounts of water vapor that could be harnessed using advanced condensation techniques. Securing a reliable source of water on Mars is not just about quenching our thirst, it's about laying the foundation for a thriving Martian civilization. Section 6. Cultivating the red soil Martian agriculture. Growing food on Mars presents a unique set of challenges. The Martian soil, while containing some essential nutrients, lacks the organic matter found in Earth's soil. The thin atmosphere and harsh radiation further complicate matters. Traditional farming methods will need to be adapted or entirely reimagined for the Martian environment. Hydroponics, a method of growing plants in nutrient-rich water solutions, offers a promising solution. This technique eliminates the need for soil altogether and allows for precise control over growing conditions. Aeroponics, where plants are suspended in air and their roots are periodically sprayed with nutrients, is another viable option. This method is even more water efficient than hydroponics and could be ideal for the Martian climate. Imagine vertical farms bathed in artificial sunlight, producing fresh fruits, vegetables, and even grains. These Martian farms would not only provide sustenance but also create pockets of green serenity amidst the red planet's stark beauty. Section 7. Life under a crimson sky. The human experience on Mars. Living on Mars would be an experience unlike any other. The Martian day, slightly longer than Earth's, would dictate a new rhythm of life. The lower gravity, about 1/3 that of Earth's, would take some getting used to. But perhaps the most profound changes would be psychological and social. The isolation and confinement of living in enclosed habitats, far from home, would test the limits of human resilience. Creating a sense of community and purpose would be crucial for the well-being of Martian settlers. Imagine celebrating holidays under a crimson sky, sharing stories of Earth, and forging new traditions unique to Mars. The challenges of living on Mars would undoubtedly foster a spirit of innovation and collaboration. It would also force us to confront our humanity, our strengths, and our weaknesses in ways we never have before. Section 8. A Martian menagerie, introducing life to a barren world. The introduction of animals and microbial life would be essential for creating a truly self-sustaining Martian ecosystem. Animals could graze on Martian vegetation, providing a source of protein and helping to fertilize the soil. Microorganisms would play a crucial role in breaking down organic matter, recycling nutrients, and enriching the soil. However, introducing life to another planet raises profound ethical considerations. What are the potential consequences for the Martian environment? Do we have the right to impose Earth-based life on another world? These are questions that require careful consideration and open dialogue. Imagine a future where Martian parks teem with genetically modified insects, pollinating crops and adding a touch of vibrancy to the landscape. Picture children marveling at the sight of birds soaring through a Martian sky, a testament to the resilience and adaptability of life itself. Section 9. Powering a civilization energy on Mars. Establishing a permanent human presence on Mars requires a reliable and sustainable source of energy. Solar power, while abundant on Mars, is less efficient than on Earth due to the planet's greater distance from the Sun. Dust storms, which can engulf the entire planet, pose an additional challenge. Nuclear power, with its high energy density and independence from sunlight, offers a compelling alternative. Small modular reactors could provide a constant source of power for Martian settlements. Other potential energy sources include geothermal energy, harnessing the planet's internal heat, and wind energy, utilizing the Martian winds. Developing a diversified energy portfolio will be crucial for ensuring the long-term sustainability of a Martian civilization. Section 10. Building a new home technology and Martian infrastructure. Constructing habitats, transportation systems, and other essential infrastructure on Mars will require a blend of cutting-edge technology and innovative engineering. 3D printing, using Martian regolith as a building material, could revolutionize construction on the red planet. Robots, controlled remotely from Earth or operating autonomously, would play a vital role in building and maintaining Martian infrastructure. Imagine self-driving rovers transporting resources across the Martian landscape, while drones survey the terrain and assist with construction projects. These technological advancements would not only facilitate our presence on Mars but also drive innovation here on Earth, leading to new materials, construction techniques, and robotic systems. Section 11. A Martian Genesis. Ethical and societal considerations. The prospect of colonizing Mars raises profound ethical and societal questions that extend far beyond the technical challenges. Who has the right to claim ownership of Martian land and resources? How do we ensure that Martian settlements are governed fairly and equitably? What kind of society do we want to create on Mars? These are questions that require careful consideration and open dialogue, involving not just scientists and engineers but also ethicists, philosophers, and the global community. The colonization of Mars presents an unprecedented opportunity to reimagine our social structures, to learn from the mistakes of the past, and to create a more just and equitable society on a new world. It's a chance to write a new chapter in human history, one that reflects our shared humanity and our boundless potential for exploration and discovery. Imagine a future not so far away. A future where humanity has not only reached Mars but has begun to thrive there. Private companies have launched daring missions to Mars, driven by the promise of new frontiers and untapped resources. They have established outposts and even small settlements. These pioneers are the first to live and work on the red planet, turning science fiction into reality. But then it happens. A bold CEO claims a huge chunk of Martian territory for their corporation, envisioning a new era of corporate dominance beyond Earth. They plant their flag, a symbol of ownership, in the red dust, marking their territory in a land that belongs to no one. Not to be outdone, a powerful nation declares sovereignty over an even larger region, igniting a new kind of space race. The space race has morphed into a land grab, but this time the stakes are astronomical. The competition is fierce, and the implications are profound. This scenario seems like science fiction, yet the seeds are being sown today. The ambitions of private companies and nations are pushing the boundaries of what we thought possible. As we push the boundaries of space exploration, we must confront a fundamental question: who owns Mars? Is it the first to arrive, the first to claim, or does it belong to all of humanity? The answer is far from simple. It delves into the complexities of international law, ethics, and the very nature of humanity's relationship with the cosmos. It delves into the complexities of international law, ethics, and the very nature of humanity's relationship with the cosmos. The Outer Space Treaty of 1967, which states that space is the province of all humankind, is being tested like never before. The idea of owning a celestial body may seem absurd. How can one claim a piece of the universe as their own? Yet, the drive to explore and claim new territories is deeply rooted in human history. How can one claim a piece of the universe as their own? This question challenges our understanding of ownership and our place in the cosmos. Yet, history is replete with examples of nations and individuals claiming ownership of what they did not create. From the age of exploration to the colonial era, the desire to claim and control new lands has shaped our world. From the land we inhabit to the oceans we traverse, the concept of ownership is deeply ingrained in our social fabric. But space is different. It is vast, uncharted, and belongs to no one. But can these earthly notions be applied to the vast expanse of space? As we stand on the brink of a new era of exploration, we must ask ourselves, what kind of future do we want to create? One of cooperation and shared progress, or one of competition and division? The choices we make today will shape the destiny of humanity in space. Will we work together to explore and share the wonders of the cosmos? Or will we repeat the mistakes of the past? The future of Mars, and perhaps all of space, depends on our decisions. As we look to the stars, let us remember that the universe is vast enough for all of us. Together, we can build a future that reflects the best of humanity, not the worst. A future where Mars is not just a new frontier, but a new beginning for us all. The Outer Space Treaty of 1967, a cornerstone of international space law, states that no nation can claim sovereignty over celestial bodies. This treaty was a monumental step in ensuring that space remained a realm for peaceful exploration and scientific discovery, free from the territorial disputes that have plagued Earth for centuries. This treaty, signed during the Cold War, aimed to prevent a catastrophic space race and ensure that the exploration and use of space benefited all humankind. The geopolitical tensions of the era made it imperative to establish a framework that would prevent the militarization of space and promote international cooperation. However, the treaty is silent on the claims of private entities. As private companies have become increasingly involved in space exploration, this omission has become a significant point of contention. This ambiguity has led to a debate about whether the treaty's principles apply to corporations or individuals. Legal scholars and policymakers are grappling with the question of how to interpret the treaty in the context of modern space activities. Some legal experts argue that the treaty's silence on private ownership does not imply permission. They believe that allowing private claims could undermine the treaty's intent to keep space a global commons. They contend that the treaty's overarching goal of preventing national appropriation extends to private entities. This perspective emphasizes the need to maintain space as a shared resource for all humanity, rather than allowing it to become the domain of a privileged few. Others argue that the treaty's focus on nations leaves room for private ownership claims. They suggest that the absence of explicit prohibitions on private ownership indicates that such activities are permissible under international law. They point to the treaty's provision allowing for the use of space by non-governmental entities. This clause has been interpreted by some as a green light for private companies to stake their claims in the final frontier. This legal gray area has significant implications for the future of Mars exploration. As humanity sets its sights on the red planet, the question of who has the right to own and exploit Martian resources becomes increasingly urgent. If private companies can claim ownership of Martian territory, it could create a situation where a select few control access to resources and opportunities on the red planet. This could lead to a new form of colonialism where the benefits of space exploration are concentrated in the hands of a few powerful entities. This scenario raises concerns about equity, fairness, and the potential for exploitation. Ensuring that space remains a domain for all humanity rather than a select few will require careful consideration and potentially new international agreements to address these emerging challenges. As we move forward into this new era of space exploration, it is crucial that we revisit and possibly revise the Outer Space Treaty to reflect the current realities and future possibilities. Only through international cooperation and a shared commitment to the principles of equity and fairness can we ensure that the final frontier remains a place of wonder and opportunity for all. Beyond the legal complexities, the question of Martian ownership raises profound ethical considerations. As humanity stands on the brink of becoming an interplanetary species, we must grapple with the moral implications of our actions on Mars. Is it ethical for any entity, private or public, to claim ownership of a celestial body? The very idea challenges our understanding of property and sovereignty. Mars, a planet that has existed for billions of years untouched by human hands, now faces the prospect of being divided and owned. What about the potential impact on future generations? The decisions we make today will shape the future of space exploration and the legacy we leave behind. Will Mars be a place of shared human achievement or a battleground for corporate and national interests? Should we not treat Mars as a common heritage of humanity, a place for scientific discovery and exploration for all? The notion of Mars as a shared resource emphasizes cooperation over competition, fostering a spirit of unity and collective progress. The ethical arguments against ownership often center around the idea of the common heritage of mankind. This concept, rooted in international law, suggests that certain spaces should be preserved for the benefit of all, rather than exploited for the gain of a few. This principle, enshrined in the Law of the Sea Treaty, suggests that certain areas beyond national jurisdiction, such as the seabed, should be managed for the benefit of all humankind. By drawing parallels between the deep sea and outer space, we can better understand the ethical considerations at play. Proponents of this view argue that Mars, like the seabed, should be considered a global commons, accessible to all and protected from exploitation. They envision a future where nations and private entities work together to explore and study Mars, sharing knowledge and resources for the greater good. However, others argue that ownership can be a powerful driver of innovation and progress. They believe that the promise of ownership and profit will spur investment and technological advancements, accelerating our journey to becoming a multi-planetary species. They contend that allowing private companies to own Martian land would incentivize investment in space exploration and resource development. By creating economic opportunities, they argue, we can unlock the full potential of Mars and ensure sustained interest and funding for space missions. They believe that the economic benefits generated by such ventures would outweigh the ethical concerns. The debate over Martian ownership is complex and multifaceted, reflecting broader questions about our values and priorities as a species. As we look to the stars, we must carefully consider the ethical frameworks that will guide our exploration and ensure that our actions reflect the best of humanity. Section 4. Martian pioneers, or corporate subjects. Imagine being a settler on Mars, part of a pioneering community establishing a foothold on a new world. But instead of answering to a democratically elected government or a global body, you find yourself under the jurisdiction of a corporation. The land you live on, the resources you use, even the air you breathe are all controlled by a corporate entity whose primary interest is profit. This scenario may seem far-fetched, yet it highlights the potential consequences of unchecked corporate ownership on Mars. Settlers could become indentured laborers, beholden to their corporate overlords for basic necessities. The principles of democracy, freedom, and self-determination could be eroded, replaced by a system where profit reigns supreme. Furthermore, corporate ownership could exacerbate existing inequalities. Access to Mars, once the dream of humanity, could become the exclusive domain of the wealthy and privileged. The opportunity to build a new society, free from the constraints of Earth, could be lost to the pursuit of profit. Section 5. Science stifled or unleashed. The scientific community has a vested interest in the question of Martian ownership. Mars is a treasure trove of scientific knowledge, holding clues to the history of our solar system and the potential for life beyond Earth. Unrestricted access to this scientific wonderland is crucial for advancing our understanding of the universe and our place within it. Some scientists fear that private ownership could hinder scientific progress. Corporations, driven by profit, may prioritize resource extraction over scientific exploration. They could restrict access to valuable research sites or control the dissemination of scientific data, hindering the collaborative spirit of scientific inquiry. However, others argue that private investment is crucial for funding ambitious scientific endeavors. They believe that the profit motive could drive the development of new technologies and accelerate the pace of discovery. They point to the increasing role of private companies in space exploration, such as SpaceX and Blue Origin, as evidence of the positive impact